This video will be tackling the dreaded clock problem in geometry. Students have trouble with these. They seem really difficult and they take a lot of work, but follow along, learn the method, and practice it a bunch of times and you will be fine. All right, let's get started. So now, first thing with clock problems, there are 12 of these little divisions around, and there are 360 degrees in a circle. So between the 12 and the 1 and the 2, and so on, it's 30 degrees. Now, from there are 1, 2, 3, 4, 5 minutes. So each of these is 6 degrees. Now, in easier problems, this won't be a big deal. You may not even use it, but it's good to know. So the minute hand goes 6 degrees per 1 minute. Now the hour hand goes from 12 to 1, 1 to 2, 2 to 3 every hour. So the hour hand goes 30 degrees per 60 minutes, which is then 1/2 of a degree per minute. In this series of problems, we won't be using the 6 degrees here. You do it on harder problems, so it's good to know. But do remember the hour hand goes 1/2 of a degree per minute. Take a second, write that out, make sure you've got it. Once you do, it makes this a lot easier. So now let's get started with these. So we're going to do an easy one first, 6 o'clock. So at 6 o'clock, the hour hand points straight down to the 6, and the minute hand points straight up to the 12. Let's pretend that I did that completely to scale. That is a straight angle. That is 180 degrees. Let's do a slightly harder one, but still pretty easy. Let's do 9 o'clock. At 9 o'clock, the hour hand points to the 9, and the minute hand points straight up to the 12. So there are 30, 60, 90 degrees. That is a right angle, 90 degrees. Now let's get to 440, which is a little bit harder. However, if you learn the method of doing it, they're fairly simple. It just takes some doing. So there are different ways of doing it. I'm going to show you how I do it. So now if the hour hand did not move, and yes, we know it does, but if it didn't, it would be pointing toward the 4. We're going to do a dotted line here just for scale. The minute hand points over here towards the 8 or 40 minutes. So now if the hour hand did not move, that would be 30, 60, 90, 120, 120 degrees. However, we know that the hour hand does move. It's going to move over somewhere to there. Doesn't have to be perfect, just get an idea of what it's doing. That's 120 degrees. And the movement of the hour hand will decrease that angle. As we saw up here, the hour hand moves 1/2 a degree per minute. I'm going to show it here as moving to decrease the angle, so that's a minus sign. 30 degrees every 60 minutes times 40 minutes. So that is 120 degrees minus 1/2 times 40, which is 20 degrees. So that is 100 degrees. Now I would suggest pausing the video at this point, drawing the circle out on your paper, and do the problem again twice. Now we're going to do 150. Again, if the hour hand did not move, it would point up toward the 1, and the minute hand would point over here. And the minute hand would point over here towards the 10 or 50 minutes. We're going to do a dotted line again just to see the scale. The hour hand does move, so it's going to go over here. It doesn't need to be to scale, you just need to get an idea of what it's doing. So if the hour hand did not move, it would be 30, 60, 90. So that would be 90 degrees. Put that over there. Now this time, the movement of the hour hand increases the angle. So it's going to be plus 30 degrees per 60 minutes times 50 minutes. So that is 90 degrees plus 1/2 degree per minute times 50 minutes, which is, of course, 90 plus 25, which is 115 degrees. Again, pause the video, do this twice, get it in your brain, you're going to be fine. Now we're going to do one that's a little bit harder. It's not terrible as long as you follow the method, you'll be great. If the hour hand did not move, it would point to 4. The minute hand would point to the 1 up here or the 5. So now we're going to show the movement of the hour hand. It's going to move down to there. Again, it doesn't need to be to scale. This is not, but it shows you that the angle will increase. So that is going to be 90 degrees plus 30 degrees per 60 minutes times 5 minutes. 90 degrees plus 1/2 times 5, so 2.5 degrees, which gets us to 92.5 degrees. And that is the basics of how clock problems work. They can be harder, but run through this again, conquer it, and then you can move on and do the rest of geometry. And you do not have to be scared of clock problems anymore.